So one of the critical things that we need to be able to do when writing ionic compound formulas is to know what charge various ions will have. What is the value of their charges? The octet rule and the valence of a chemical element can be used to predict your possible ion charges for elements. We know that low valence metals are going to lose their valence electrons. So group 1 elements can form +1 cations. If an element comes from group 1, it's going to form a +1 cation when it forms an ion. Group 2 elements similarly form +2 cations. High valence nonmetals are going to gain enough electrons to make 8 electrons. So we're going to determine its valence from its group number. Group 17 nonmetals would have 7 valence electrons. They can gain 1 to make a -1 anion. Group 16 nonmetals, group 16 have 6 valence electrons, so they can gain 2 electrons. Group 16 will always make -2 anions. Group 15 nonmetals are going to have 5 valence electrons. They can gain 3 electrons and make a -3 charged anion. Group 14 nonmetals can form -4 anions. And be careful when we're saying this. This is not every element in group 14. This is only the nonmetals. Same thing. So when we're talking about forming anions, only nonmetals to the right side of the staircase will be forming anions. All the rest are the transition metals. The octet rule does not work well for predicting ions in the transition metals. So for transition metal elements, we're going to use a reference table to determine what charge ions they can make. And you'll have that on your set of reference tables that you can be using on a test. So if we're looking at the periodic table and we're talking about our main group elements, not the transition elements, we can look at its position on the periodic table to determine what charge it's be. Again, group 1 is +1, group 2 is +2, group 14 nonmetals -4, group 15 nonmetals -3, group 16 nonmetals -2, group 17 nonmetals -1. So there's a nice pattern. So you can look at the periodic table, see where the element is. If it's one of those main group metals or main group nonmetals, we can use its position to determine its charge. All of the ones that are not noted are my transition metals. For those, we're going to pull up a transition metal ion charge. I've provided some of the most common transition metal ion charges. Note that many of these ions, for instance, bismuth and zinc, are only capable of making 1 charge ion. Zinc can only make a +2 cation. However, there's a variety of them on there that can make more than 1 possible ion. Iron can exist as a +2 cation, or it can exist as a +3 cation. We're going to have to need more information to determine, is iron going to be a +2 ion or iron a +3 cation. So we'll use context clues to determine which charge to use. There's a whole new class of ions, and those are our polyatomic ions. These are not single elements, but rather a group of nonmetals that are covalently bound together to form they're covalently bound units that have an anion charge. There's a couple of cations, but for the most part, they have additional electrons making an anion. We will have this table available to us on tests, so you're going to need to be looking at this polyatomic ion chart. It's very helpful to sort of memorize it. You need to know the chemical formulas of the grouping. You need to know the charge of the polyatomic ion, and you need to know the name. They each have a reserved name. So using this, and if by sort of memorizing it, you become familiar with them when you see them in chemical names or you see them in chemical formulas, you recognize them quickly. However, you do have this reference table for use to help you when you're doing your homework and on all tests. So that's how we're going to determine the charge of a particular ion.